Hi class, today we are on Saxon Math Book 4, Lesson 58, and we will be multiplying 3-digit numbers. So you guys have already practiced and learned how to multiply 2-digit numbers. I am here to tell you that multiplying by 3-digit numbers is no different, except you now have a third digit that you're going to have to multiply by. But it's the same exact process. So, especially today, because we're talking about single digits down here, we take our number and we multiply times the ones place first. So here I'm going to multiply 3 times 3. I get 9. I put my answer down there in the ones place. There wasn't even anything to carry. Okay, then I look at the tens place. I take my 3 here, multiply it times the tens place here. 3 times 2 is 6. Again, nothing even to carry in this example. So at this point, that's as far as you've gone. When we have a 3-digit number, we do the same thing a third time. We take our 3 and we multiply it now times the 1 in the hundredths place. 3 times 1 is 3. And our answer here is 369. All right, let's look at a different example. Same process. We're going to take our 3 here times the ones place. 3 times 6 gives me 18, so now I have to carry. My 1 in 18, the 8 is in the ones place, that goes down here in the answer. My 10 gets carried over here. And remember, from multiplying 2-digit numbers, I like to write a +1 so that I remember that I'm going to add that at the end. This number doesn't get multiplied, it gets added. So I've done my 3 times 6. Now I move over, I do 3 times 5. I've got 15 plus 1, so that's going to give me 16. Again, I put that 6 down here, and I'm carrying a 1, so I have to plus 1 over there. Then 3 times 4 is 12, plus 1 gives me 13, and now I could put my plus 1 over here, because really technically that's what we're doing. We're carrying it over to the thousands place. However, since I know that there's nothing more for me to multiply, this 1 just goes there in front of the 3. So now my answer is 1,368. Okay, that's how you do it. You are occasionally going to see problems in your textbook that look like this. But more often than not, you're going to see word problems that require you to multiply 3-digit numbers. Okay, so here's the first example of the word problem. There are 365 days in a year, in a common year, Every 4th year is a leap year with 366 days. How many days is 4 years in a row? So this is a little tricky. We have 365 days, and they want to know 4 years. So this year has 365, this year has 365, this year has 365, this year has 366. That's not exactly straight up repeated addition. We're going to have to think about this a little bit. Do I have 4 groups, or let me rephrase that question. Can I make 4 groups of 365 out of those 4 years? Yes, I can. 3 of them are already made for me, and this sucker over here has 366 days, so I can take one of those days and turn him into another group of 365. So we have 4 groups of 365, but what about that day that I took away? because he didn't make my groups even. I can't forget him because he's still a day in those 4 years. So I'm just going to put a +1 over there so that I don't forget to add him back in at the end. And then we multiply. Again, we start with the ones place. This number, 4, times the ones place, 5. 4 times 5 gives me 20. So my 0 goes down here, and I'm going to write a +2 because I have to carry 2 tens. 4 times 6, what is that? 24 plus 2, so 25, 26. So I'm going to carry my +2 again over here to the hundreds place. 4 times 3, what do you got? 12 plus 2, 14. So I have 1,460 days. Am I done? No, don't forget. We have to add this guy back in. So +1, and our total will be 1,461 days for our answer there. Okay, next example is another word problem. This one says tickets to the school play were $3.75 each. How much money would 3 tickets cost? So not like the last one, we don't have anything extra we need to add. We're just getting 3 tickets at $3.75 each, but here's what's tricky. There's a decimal. So, you know when we add decimals, we bring the decimal straight down. In this case, we are also going to bring the decimal straight down. You can think about it this way. It's money. Money has 2 decimal places, so our decimal is going to go right there. But I want to warn you ahead of time. When we multiply times decimals, it's not always about bringing it straight down. We put however many decimal places in the answer as there are in the problem. So in this case, I have 1, 2 decimal places. So my answer is going to have 1, 2 decimal places. Okay? We're not going to do anything more difficult than that in 4th grade, but as you get 5th, 6th grade math, there's another idea, another trick to multiplying decimals. I don't want to confuse you with that today, but I want you to know it's not the same as when we add decimals, okay? So, enough decimal talk, let's multiply our 3 digits. So we're not doing anything different than if it didn't have a decimal. We're going to start with our 3 times this place value, the place value that's the furthest to the right. So 3 times 5 gives me 15. I'm going to carry my +1 over there. 3 times 7 gives me 21. +1 is 22. So I have to carry my +2 over there. And then 3 times 3 is 9. 9 plus 2 is 11. And it's money, so don't forget to put a $ in your answer. $11.25. Our next example says when the gate of the stadium was opened for a concert, people passed through the gate at a rate of 100 people per minute. At that rate, how many people passed through the gate in 10 minutes? So the book suggests that you make a table, and in fact, they even start the table for you. They write minutes and people, and they wrote their table horizontally instead of the vertical ones that we were doing in our last lesson. So here, 10 minutes is what we want. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And they started the table all the way up to 4. They said 100, 200, 300, 400. Oh my goodness, I see the pattern. Do you? Yeah, we're counting by hundreds down here. So 500, 600, 700, 800, 900. Do I say 1000? That doesn't sound right. Right, because after 900, when we add another 100, we get 1000. Okay? So, we've got 1000 what? It's a word problem. 1000 people is our answer. But I want to talk about another way to solve that. This is just like a rate problem. 100 people per minute. So then how many people would pass in 10 minutes? We're going to take, let me do it in a different color so it stands out. We're going to take 100 people times 10 minutes. And I love this multiplication problem because I get to show you the greatest trick in the history of multiplying. See all these zeros? Those zeros are just going to get tacked onto the end of our answer. All I really need to know is what is 1 times 1. 1 times 1 is 1. So I can put a 1 over there. I put it over here because I know I'm going to have some zeros. So I didn't want to put my 1 here. Although I think in 5th grade that's what Saxon does. Anyway, I look at my digits that aren't 0. 1 times 1 is 1. And then I'm going to count my zeros. 1 0, 2 zeros, and we count this one too, 3 zeros. So if there are 3 zeros getting multiplied in my answer, I have to have if there are 3 zeros getting multiplied in my problem, I have to have 3 zeros in my answer. So 1, 2, 3, I can stick a comma in there and look, same answer, 1,000 people. All right, we have one more example. A landscape architect is designing a border of plants and trees for a parking area that has a perimeter of 256 yards. What is the approximate perimeter of the parking area in feet? So we have to convert 256 yards into feet. In order to do that, we need to know how many feet are in 1 yard. 1 yard equals 3 feet. So each of these 256 yards represents 3 feet. So we are going to multiply times 3. So again, start with the digit closest to the right. In this case, it's the ones place. 3 times 6 is 18. We're going to carry our plus 1. 3 times 5 is 15. Plus 1 is 16. Carry another plus 1. 3 times 2 is 6. Plus 1 is 7. So we have 768 yards. No, remember we multiplied by 3 because we're converting it into feet. So 256 yards is equal to 768 feet. I keep misspeaking my words today. Mrs. Duarte made a mistake. I didn't read the problem close enough. This would be the exact answer, but I did what a lot of you do on your homework. Let's read the question in this problem again. It says, what is the approximate perimeter of the parking area in feet? Approximate means round. I did all this hard work and I could have done it the easy way. I should round. 256. So, there's two ways to do this. We want to do the easiest way that's going to help us do this problem in our head. If I round this correctly, I'm going to get 260 because my 6 here is going to up that 5, and 260 times 3, that seems a little bit difficult. So instead of rounding, I'm going to use what we call compatible numbers. And I'm going to say 256. That is darn close to being 250. So did I round correctly? No. But am I approximating correctly? Yes, because when you're using approximates or estimates, you can round or you can use compatible numbers. Compatible numbers being numbers that end in 5, which we kind of ignore the 0 here. 25 ends in 5. So 15s, 25s, numbers, even if it were a multiple of 7, numbers that you know in your head that you can do really easily in your head. So 250, I can work with that really easily in my head. I'm still going to multiply it times 3. But I'm not going to go through this whole process. I'm going to say, hey, there's a 0 here, so I'm going to need a 0 at the end of my answer. And then I'm going to ignore that 0, and I'm just going to count by 25 3 times. So 25, 50, 75. And this is my approximate answer. Is it close to my actual answer? Yes, absolutely. So doing this, I kind of checked my answer, but if this were a homework problem for you, this is the one they would want. This answer would not be listed in the answer key. All right, boys and girls, if you are in my class, I'm going to see you later today, and you will need to have your lesson practice done. It doesn't need to be checked. We'll go over the answers in class. It begins on page 373. Please have that done before we meet. And then you can work on your written practice, which also begins on page 373. Hope you have a great day, and I'll see you again soon.